Alright, we're going to start out this lesson with dividing using synthetic division. Now inside the division is going to be 1, 0, negative, or 6 and negative 3. And the reason why we have the 0 in there is because we need 1 for each of the terms. And 4 goes on the outside because this is x minus 4. So 1 multiply 4, 16, 22, 88, 85. So my answer would be x squared plus 4x plus 22 plus 85 over x minus 4. And one of the things that we learned in class is that if we plugged in 4, so 4 cubed plus 6 times 4 minus 3 should turn out to be the same thing as our remainder. So 64 plus 24 minus 3 equals 85. And so that is our remainder theorem. Alright, in this particular problem, we want to know if this is a factor. So when I do 1, negative 2, negative 13, negative 10, and I'm going to divide by negative 1 because we got x plus 1, 1, negative 3, 3, negative 10, 10, and 0. So x plus 1 is a factor, and the other factor would be x squared minus 3x minus 10. If we continue to factor this, we try to break this down, and we need two numbers that multiply up to be 10 and add up to be negative 3. So the two numbers that multiply up to be negative 10 would be negative 5 and positive 2. And that would be your complete factor. If in the case that we are not given x plus 1 to be a factor like we were here, we could always check our graph to find zeros. Alright, in this problem, we got x squared plus x squared minus 22x minus 40. And when I look on my graph, it crosses the x-axis at 4 and 5 and negative 2. And what you can do is you can plug this in for y1 or y2 and y1 equals 0. And you can find these as the 3. And so I'm going to use the x minus 2, which means I'm going to have plus 2. And we really could use either one. So 1 brings down, negative 2 is negative 1, and then this is positive 2, which is negative 20, and positive 40, which is 0. And so because this is minus 2, we know the factor is x plus 2. And we're left with x squared minus x minus 20. And then because 4 and 5, actually that should probably not be 4 and 5, x minus 5 and x plus 4, this was actually supposed to be a negative 4. And we have our answer. Alright, so we're given this problem, and we know that factor is x minus 5, and we want to find k right here. So I'm going to put this in, and we have 5 on the outside. So this turns out to be 3, 15, 20, 100, k plus 100. And then when we multiply this, this is going to be 5k plus 500, which means we got 5k plus 502. Now in order for this to be perfect, 5k plus 502 must be equal to 0. So I'm going to subtract 502. Divide by 5. And since this doesn't come out even, I'm just going to leave it as a fraction. And that's going to be my answer. And that's it for 4-3.